Hello everyone and welcome to Science Visualized. Today we're looking at how mass spectrometry, abbreviated as MS, works. First, you start by injecting a sample which goes straight into the ionization chamber. That's where it's heated and vaporized. Then after that, it's bombarded with high energy electrons, and as a result, you end up with a sample losing one electron, so the sample becomes charged because it will become a radical. So let's say you start with the sample S, then after that you bombard it with high energy electron, you end up with S losing one electron, so it becomes charged, and now it becomes very unstable, and some of it will start to break, so it results in what's called fragmentation. It breaks into smaller particles or smaller fragments which has different mass to charge ratio, so m/z. And then that's fed into the mass analyzer, which can either use an electrical field or a magnetic field. So for example, you could have a positive charge and a negative charge electrical field, and as the fragments are fed into the electrical field, you end up with a deflection depending on the mass to charge ratio. So some of them will be heavier than others, and as a result you end up with separation. So you end up separating them, and that's basically what the mass analyzer does. Depending on the type of mass analyzer, instead of the electrical field, you could also use a magnetic field, so north and south, and then you end up separating. Some instruments are called double focusing, and that one actually passes the sample through a magnetic field first or an electrical field first, and then next a magnetic or electrical field. So you end up actually separating in two stages, and that becomes really sensitive, and that's actually used in determining the exact mass of the sample. So after you get through the mass analyzer, that information is fed to the detector, which then identifies the mass to charge ratio, and from there that information is fed to the display where you actually are able to see the data. And remember, the mass spectrum looks like peaks, it looks like lines, where each line corresponds to different mass to charge ratio. And then the vertical axis is percentage abundance. You can review the other video that I prepared on this, but the tallest peak is called the base peak. And then the farthest to the right most of the time is the molecular ion, so M+, also called the parent ion, which is used in determining the molecular weight of the sample. Also review my video on the fragmentation patterns, which can be used to identify the types of fragment and eventually build up to identify the molecule that you started with. Mass spectrometry is very important in identifying the molecular weight of the sample, the size of the sample, the exact mass, and from there the molecular formula. If you like this presentation, please subscribe. Thank you.